This is lesson 910 from Algebra 1. This is the end of chapter 9, which dealt with exponential functions and logarithms. And this is where I really think you're going to see it kind of all pull together. You're going to start to see the real purpose of logarithms and why they're useful in mathematics. So if you've been wondering that this whole time, what is this crazy thing and why did we make it up? I think you're going to see that here. This is going to answer that question that's kind of been lingering throughout the chapter. So we're going to deal with solving exponential equations. And when I say solve, I mean figure out what x equals when x is located up in the exponent. If you think back to like the first lesson in this chapter, there were questions where we were trying to solve that, and we really didn't have a way to get at that thing if it's up in the exponent. We did some estimation with our calculator, but we never actually solved it. And so that's what we're getting to today. So I do have some steps up here for you, but I think I'd prefer to work through this first example first. And then as we do the steps down here, I'll kind of point out the wording up here, and then you can get those things copied down. So we'll come back to that in just a second. Looking at this example 1, notice it just says to estimate the solution to 5 to the power of x equals 20. So this number here is approximately what? Well, we know it's got to be something less than 2. Right? Because if it were a 2, we would have 5 squared equals 25, and this is a little less than 25. So I would take something like we know that it's less than 2. Probably a more accurate way to write it would be to say it's somewhere between 1 and 2. I'd be okay with either one of those answers, though. So somewhere between 1 and 2. So we're talking like 1 point something something. Okay, something awfully close to 2. So now we're actually going to solve it. So let me rewrite my equation here. It's 5 to the power of x. Oops, sorry. 5 to the power of x equals 20. So here's the beauty of this method here. Is up until now, we haven't had a way to cancel out this x when it's up in the exponent. We haven't had a way to move it. But now we do. What I'm going to do is I'm going to take a common log on each side. Okay, now, technically I could do this step taking any log that I want to, a log with any base. There's a reason, though, that I'm choosing a common log. Reason for that is the common log shows up in your calculator, right? So I'm going to be able to do a lot of this with my calculator in just a minute. And then I'm going to want to take this x and drag it down out of the exponent, because remember those properties of logs we learned about? If you've got this exponent here, you can move it down in front. So we end up with x times log 5 equals log 20. Okay, x times log 5 equals log 20. And then this has become a multiplication problem, right? Knowing that it's a multiplication problem, notice that x is no longer up in the exponent. Now I can solve this with division. So I can divide on both sides by log 5. Cross these two out. And then this, because this is all common logs, can go straight into my calculator. Okay? So I am going to do log 20 divided by log 5. And I end up with 1.86 about. And so we end up with x equals 1.86-ish. Okay, we know that we rounded that. I guess I should have used the little squiggles here. And if you think back to our estimate, that's about correct, right? It's something a little bit less than 2. Okay, so now let's talk about those steps that we took. First step is to isolate the exponential piece of the equation. We didn't really have to do that here because it was already isolated. If you look down at like example 2, and I'm sorry my ink smeared a little bit here, but 4 times 2 to the x, the 2 to the x is the exponential part. So just like any other equation solving that we've done, if there's other stuff outside of that exponential piece, we need to get rid of that first. So like in this one, I'm going to divide by 4 before I do anything else. That's all that first step means. Take a common log of each side. So I did that here. Move the exponent down in front based on those properties of logs that we talked about, and then solve with division. Okay, that's going to work anytime your x is up in the exponent. So let's try a couple more. Example 2. So like I was just saying, First thing I would do here is get rid of that 4 that's in front. So I'm going to divide by 4. I'm going to move over here. I get 2 to the power of x equals 12. Now, when I'm at this step right here, I usually like to try to estimate this in my head to get an idea of, what I'm expecting my answer to be. Let's see, 2 to the 4th is 16, so that's a little too big. 2 to the 3rd is 8, so I know it's going to be somewhere between 3 and 4. So let's find out what it really is. I'm going to take a common log, move my exponent down in front. Sorry, this side got all kind of stacked around, but this should now say x times log of 2 equals log of 12. And then, because this is now multiplication, I can solve it with division. And this can go into my calculator. So I'm going to do log 12 divided by log 2. The one thing you have to look out for with these, make sure when you're doing this division right here that you close this parenthesis on this log first. Okay. And we end up with 3.58. I don't know if I gave directions here on rounding, but I would say 2 decimal places is probably safe. Okay. Okay, so let's think about that next one. On that next one, first thing I would do is probably subtract the 7. So we end up with 8 to the power of x equals 147. Log on each side. Move the x down in front, so we end up with x times log 8 equals log 147. Divide. And let's see. Log 147 divided by log 8 leaves me with 2.3. So I'm going to probably go 2.40. And again, all of these I should really be using that kind of squiggle to show that I rounded that answer. But we get the idea. Okay, that very last one looks a little more complicated. I kind of threw this one in here to show you, like, yes, this one has more steps, but none of the steps are all that, much more complicated than anything else you've seen. This one takes a little bit more work to isolate the exponential. So this is the piece that I want isolated. That's the exponential piece. So we have to get rid of this 5 and get rid of this 12. Careful about what order you're doing that in. Remember, we always get rid of addition and subtraction first. So I'm getting rid of the 12. Let's see, 98 plus 12 is 110. Okay. And then to get rid of this 5, this is a division problem, so I'm going to multiply by 5. Gosh, I didn't make enough colors for this, but okay, so multiply by 5, multiply by 5. And so over here we end up with 3 to the power of 2x minus 1. Probably good, I'm about done with the purple. Equals 550. 5 times 110. Okay, so even though this looks a little more complicated, I'm still going to treat that next step the same way I've done for all the others. I'm going to take that common log on each side, and I'm going to take this whole piece as an exponent and drag it down in front. And I think the easiest way to do this, or the best way to write it, would be in parentheses. So I'm going to show this as like 2x minus 1 times this log 3 equals log of 550. And then I'm still going to take this, so this I'm going to leave alone for right now, and I'm going to get rid of that log 3. So I'm going to divide by log 3 on each side. Okay, this is the part that's going to go in my calculator. So log of 550 divided by log 3. I end up with this 5.74. And I'm probably going to write it as a rounded number for right now. Gosh, I'm out of space here. Sorry, I'm going to move up the side. Maybe. There we go. Okay, so this is example 3 continued here. So what I have right now is 2x minus 1 over on the left. And then I ended up with that 5.74 number. And now this is just a two-step equation. So normally in all the other problems, we were done at this step. I didn't have to worry about finding this extra space, right? But now I'm going to treat this like a two-step equation and just get rid of this 1 and this 2 using this decimal. Now, remember that I rounded that decimal? I don't really want to use the rounded version, so I'm going to try to keep this in my calculator as much as possible. I'll write down the steps that we're taking. So the first thing I would do is add 1 and add 1, right? So in my calculator, I'm just going to keep that decimal there and add 1. So I get 6.74. And then my next step would be to divide by the 2 and divide by the 2. So I'm going to take this thing and divide it by 2. And that way I kept the whole decimal in there all the way through. And I can give my answer of x equals 3.37. So if there's other stuff in the exponent besides just an x, you just deal with that when you get down to the end of your problem. Okay, so you can divide, you can multiply, you can subtract, whatever you need to do. Okay? All right, sorry for the crazy turnaround there. Let's go on to that next page. Okay, so looking at this one, log base 3 of 60. I've asked you to do these so far where you've had to do like, log base 3 of 27 because we know 3 to the third power is 27. I've given you ones that you can do in your head. This one you can't really do in your head, okay? And here's why. What this question is really asking, if we say this is equal to x and we spin it around using that circle method thing, gosh, all my pens are running out. That used to be used right now. Okay, if I spin that thing around, I end up with this. 3 to the power of what makes 60? Okay. Well, we know how to solve this, right? This is what we did on the last page. We know exactly how to solve this thing. We're going to take a common log on each side. We're going to move this x down in front. So we get x times log 3 equals log 60. Then we're going to divide by log 3 on each side. So log 60 divided by log 3. Whoopsie, I almost made that mistake. Divided by log 3. Still almost made a mistake. And we end up with 3.72. So that means log base 3 of 60 is 3.72. Okay? But I want you to pay attention to what we did, and I should have written this down right here. So right here, we divided by log 3. Okay, see this division right here? Log of 60 divided by log of 3 that we've done over and over and over again. Look at how those numbers compare to your original problem. What we really just did there is we did the log of this number divided by the log of this number. That will always work for you. So if you are working with a calculator that doesn't do the log base function that some of our calculators have, or if you are working with a calculator that you can't do a log in a base other than 10, this is your workaround right here. This is called the change of base property. And technically this is how it looks mathematically. This is like the symbols for it. And it's saying if you're trying to do log base something of something, you can do the log of x divided by the log of a using any base you want. So this b here, notice it again, it's x over a, just like here it was 60 over 3. This b means you could use any base that you wanted. Again, we're choosing the common log because that's a base that our calculator can handle. So we're always going to do common logs for this change of base, even though mathematically you could do anything you wanted. Okay? So when I'm looking at this example 4, if we think about that shortcut, we could go through this whole process every time. And I think it's important for you to see this process so that if you ever got stuck on one of these or next year when you don't remember how to do this, You can at least do this calculation, but we can really just solve this by doing log 50 divided by log 5. Okay, every single time that will work. Log 50 divided by log 5. Log 50 divided by log 5 looks like 2.43. And again, just to keep in mind what that means if I do 5 to this power, it should come out to equal 50. So to check that in my calculator, I'm going to go 5 to the power of, and then to keep that whole decimal in there, I'm going to use the ANS. And there you go, it's 50. So for that next one, I would do log of 1042 divided by log 3. Takes longer to type into a calculator than anything. Okay, 6.33. Okay, so those should be quick and easy. As far as like a test or quiz goes, this is my expectation for showing work, that you show me what you're typing into a calculator. You don't have to go through this process every single time, but you should show me what you're typing in. Okay, that's really it for this lesson. So for being kind of a big culminating lesson, I hope that you found that the math was not actually that difficult. But this is kind of the main event as far as logarithms go. This is the big exciting thing that logs are used for. So hope you enjoyed. All right, have a great night.